Hello math lovers, and welcome to another video for our channel. Today we will take a look at another problem of AIME number 1, so the American Invitational Mathematics Examination, which is practically the second phase of United States of America Math Olympiad, a very prestigious competition. And only, I guess, the best 400 or 500 students from the two AIME examinations are invited to the final stage, which is the USAMO, let's call it, so USA Math Olympiad. And so we take today a look at another problem of this examination, which requires that find the number of ordered pairs x and y where both x and y are integers between -100 and 100 inclusive, such that 12x squared minus 6y minus 6y squared is equal to 0. As always, please pause the video and give down in the solutions give down in the comments your solution if you want to take a try at it, and then at the end let's compare our solutions and our answers. As always, we have covered the solution in order to go through it step by step together, and so we of course rewrite the request of the problem. So we are asked to find the numbers x, y, both integers between -100 and 100 inclusive, such that 12x squared minus 6y minus 6y squared is equal to 0. Of course, the first thing we should do is to try and rearrange this expression over here in order for us to be more simple to be simpler to find the solutions and to count the pairs of solutions. So we try to rearrange the given expression so we can factorize it. By the given expression, what we should do is that minus xy, we express it in another form, or that minus xy is equal to 8xy minus 9xy. So the given expression is equal to this new expression, 12x squared plus 8xy minus 9xy minus 6y squared. We, on this first part over here, we factorize for x, and we have that for x is multiply to 3x plus 2y, and on the second part of the left hand side we factorize 3y and we get minus 3y, which multiplies 3x plus 2y. We see that the expression in the brackets are equal, so we can factorize it, and this expression over here at last is equal to 4x minus 3y times 3x plus 2y, which is equal to 0. So the given equation is of the form 4x minus 3y times 3x plus 2y equal to 0. This is much simpler to reason on this form of the equation, and we will try to find the number of ordered pairs given in this equation. The solution to this equation, of course, are such that when this first expression is equal to 0, or when this second expression is equal to 0, or when both expressions are equal to 0. We will try this to solve these cases separately and to count at the end the pair of ordered numbers x and y. The first case is when 4x minus 3y is equal to 0, or then we factorize. Let's say we take 3y on the other side, on the right hand side, we divide both sides by 4, and we have that x is equal to 3y divided by 4. So in this case, we see that y should be a multiple of 4 in order for both numbers y and x to be integers. But we know that between the numbers minus 100 and 100, of course, there will be, let's say, 100 divided by 4 multiples of 4 times 2, because we have from minus 100 to 100 plus 1. This plus 1 over here is a solution 0, 0. So we will have 50 plus 1, in total 51 solutions in this case. So there are 51, let's say, multiples of 4 between minus 100 and 100, which produce all of them, which produce an integer x. So we have 51 solutions in this case. The second case is when 3x plus 2y is equal to 0, which gives that, of course, we take 2y on the right hand side, divide by 3, and we have that x is equal to minus 2y divided by 3. In this case, we see that y should be a multiple of 3 in order for x to be also an integer. We know that between minus 100 and 100, of course, there will be on each side, let's say we divide the size from minus 100 to 0 and from 0 to 100. In each side, there will be 99 divided by 3 times 2, because as we said, there are two segments, minus 100, 0 and 0, 100. So there will be 33 times 2, 66 solutions, plus 1, which is the couple 0, 0, the order pair 0, 0. So in this case, there will be in total 67 solutions in this case. And the last case is when 4x minus 3y is equal to 0 and 3x plus 2y are equal to 0 contemporarily. In this case, there is only one solution possible for the order pair xy is equal to 0, 0. So finally, we say that there are in total 51 plus 67 plus 1 equal to 119 solutions. But attention, because as we explained during our solution, we have triple counted the pair 0, 0. In the first case, in the second case, and in the third case. So finally, the real number of pairs of solutions for this given equation is 119 minus 2 is equal to 117 solutions. I really hope that the people who took the AIME test have not fallen for this, let's call it, dirty little trick where you triple count the, let's say, the pair 0, 0. And did you have a solution like this for this problem, or did you solve it in another way? If so, let me know in the comments. Thank you very much for your time, and see you on our next videos. Bye.